Section 10.2, the parabola. A parabola is the collection of all points P in a plane that are the same distance d from a fixed point F as they are from a fixed line D. The point F is called the focus, and that's here. This is my focus right here, okay, of the parabola. And the line D is the directrix. Okay, and that's this line here. That's my directrix. Okay. As a result, a parabola is the set of points P for which, now they're saying DFP, and that means distance from F to P. So that would be here. That's my distance from F to P. And they say that has to equal the distance from P to D. Now remember, the directrix is going to be this line that's created from a right angle from the axis of symmetry. Now again, when we've dealt with parabolas before, we had very little information. Essentially all we knew was the vertex, we knew the axis of symmetry, and where I crossed the x-axis, and the y-intercept, of course. But that's all we really ever knew about parabolas. Now we're going to get much deeper in this section. So keep in mind here, this DFP is my distance from F to P, and then my distance from P to D. Now keep in mind here, these are going to be right angles that we get. So with all these points, let's say I was talking about this point right here, then it would be from F to P, and that would be my distance. That would be my DFP. And then if I drew a line straight down here, we would see that those would actually be the same distance. That's what's really cool about this, and that's really how they're defined. Now there are definitely some other things to consider here, a lot more information here. Essentially, we just talked about PF, DFP, DPD, and the vertex. So how do I find my vertex? Essentially, the way I find my vertex is I would essentially say, hey, this distance here from my F to my V is going to be A, and that's what we see down here. And then from that vertex straight out, a distance of A, and a line that's going to be perpendicular to that is going to be my directrix. So again, we just use this information if we understand the structure here, and just realize if I have a vertex, I just go A in and A out. And A in, A out, that would give me both the focus and the directrix. Okay, if I didn't know the vertex, let's say I knew the focus, and let's say I knew A, then I would just have to take A downward here. And then when I take it downward, I can get to the vertex. So I can use this information back and forth if I understand the basic picture. And one more thing to understand here is if I went from F here to the directrix, that would be 2A. And that's what we see below. So with all this information together, it makes it easy to come up with equations for it sometimes, and also graphing it becomes a little easier. So I want to show you one thing about this equality that we get here. And this is going to help us with a formula. If we get a formula, sometimes it's a lot easier to work with if I can just memorize a simple formula. So let's talk about how this works. So here it is. So here's a sideways parabola, and this is something that might be new to some of us. And we're going to actually just talk about this and kind of break it down a little bit. So do you remember the equation from the previous page? It was DFP equals DPD, oops, capital D. Now notice what F is here. F is the point A0, and P is the point XY. And we're just going to use those two pieces of information along with Euclidean distance, which simply tells us that I would get. And essentially, I'm just taking the distance from A0 to xy and xy to negative ay for the second distance. And to break that down, this is what we get. So here it is. So I get the x minus the a, and then the y minus the 0, and I square those and add them. And that's a Euclidean distance. And I do that for both sides. Now from here, this is just an equation. So to solve this equation, I'm going to square both sides. And this is what we end up with. And from here, I'm going to square both sides from the x minus a squared, and I'm going to multiply that out. And then the x plus a squared on the right side, I'm also going to multiply that out. And this is what we get. And then from here, I'm missing my y squared on the left side, so I got to rewrite this. And we get this. Now all I'm going to do here is subtract x squared from both sides. And there's a reason why I'm doing all this. And I'm also going to subtract a squared and subtract a squared from both sides. So negative x squared, and that's it. Those two things from both sides, and watch what we end up with. And then if I add 2ax to both sides, I get y squared equals 4ax. And that's our formula for any sideways parabola. So there it is. Once I have that, I know it's a sideways parabola because it's the y being squared. Now think about what the a meant. The a was my distance from the vertex to the focus. And it was also the distance from the vertex to the directrix. So that's what my a represents here in the formula. So that's kind of nice too, and that comes in handy as well, given certain information. So if I'm given an equation and I can write it in this form here, then I'll actually be able to graph it or give all the necessary information for that. Whether it be I can tell the focus, the directrix, I can give it so much information. So then for the upright parabola, what do you think the formula for this would be? So this would be x squared equals 4ay. So to kind of see them both together again, this one's y squared equals 4ax, and the other one is x squared equals 4ay. Now again, keep in mind I can move this thing around. So let's say I wanted to move this thing upward. So let's say I wanted to move it up here. Then that would be my y I'm actually moving, right? And it would be going up 1. So I would write this x squared. And let's say I just moved it up 1 unit. So then this would be 4a, and then this would be a y minus 1. Because remember, what makes this 0 here? It would be 1. So that would actually move it up 1. All right, so there it is. So with the examples, we'll start to get into that in more detail. There is one more thing for us to consider before we leave. So take a look at this. My directrix, when I'm dealing with a upright parabola, is going to be a y equals ay, or y equals negative a, excuse me. And then when I go over to the vertical one here, or I should say the one opening sideways here, notice the directrix here is x equals negative a. So x equals some number is going to give me a vertical line, and y equals some number is going to give me a horizontal line. So that kind of tells me some information there as well. So I know if it opens upwards or downwards, it's going to have a horizontal directrix. And if it's opening sideways, it's going to have a vertical directrix. So those pieces of information are just kind of nice to be able to visualize, so when I actually write solutions out, it makes sense where everything's coming from. It definitely complements what we're talking about.